This is Trig Identities part number 13. And I know this is going on and on and on, but you need to understand everything that's going on here. Do you remember the law of cosines, which I was talking about in the previous video? We're going to get back to this now. That's right, we're going back to trig identities, or to law of cosines, and it's very important we do. Alright, we have a triangle here. It's A, B, C. Okay, this is A, B, and C. Now then, what we have here is little c, little a, little h, little I, little b, which is the length of AC, and b minus I, which is the length of AD. Hopefully I won't have to say that again. But just keep in mind that the length of DC is I, and the length of AD is b minus I. So the length of AC is b, little b. Okay. Now let's go over to triangle BDA. What is triangle BDA? B, D, A. That triangle right there. We're going to go to it. Now, as you see, it's a right angle triangle, because there's the right angle right there. Now, if it's a right angle triangle, we can use the Pythagorean Theorem to solve it. How do we do that? Little c squared, which is the length of BA, is equal to little h squared. Well, what's little h? The length of BD, plus b minus I squared. Where do we get the b minus I? B minus I is the length of AD. Okay? Now, how do we solve b minus I? Well, what we're going to do is we're going to use the FOIL method over here. And so we'll have b squared minus 2bi plus I squared. So we're going to leave that equation alone for a minute because we have to go to something else. Now then, let's go to triangle CBD. Where is CBD? CBD. This one right here, this tiny one right here. As we can see here, this is also a right angle triangle. So once again, we can use the Pythagorean Theorem to solve it. So now we have little a squared equaling little h squared plus little I squared. This here, the length of BC, is equal to BD squared plus DC squared. Okay? Now then, what if we rearranged all this? Well, we can do that. We can subtract I squared from both sides of this equation, therefore saying a squared minus I squared equals h squared. Now then, what can we do with this? Well, I'll tell you what we do with this. You see that h squared up there? We're going to change h squared to this one. So instead of saying h squared, we're going to say a squared minus I squared. And that's how we start coming up with all this. So now, you have c squared, which equals a squared minus I squared plus b squared minus 2bi plus I squared. Now, if you have a positive I squared here and a negative I squared there, what's going to happen? Those two terms are going to fall out. Boom, they're gone. So now what do we have left? C squared equals a squared plus b squared plus 2bi. Alright, now then, what is the cosine of this great big letter C? Letter C is an angle. Letter C is this angle right here. This is letter C. Okay? Now then, what's its cosine? Well, that's real simple. The cosine of C is the adjacent angle over the hypotenuse. What's the hypotenuse? The hypotenuse is BC. BC is the hypotenuse of BCD. What is the adjacent ray? The adjacent ray to this is going to be DC, the length of DC, which is also I. So, the length of the adjacent side over the hypotenuse is cosine of C. Now, here's what we can do. We can take both sides of this equation and multiply it by A. That eliminates that term, that eliminates that term. Now we can say little a times cosine of C is equal to little I. So the length of little I is little a times the cosine of C. Well, we can use the substitution method now. So now C squared equals A squared plus B squared plus 2B. Now what are we substituting the I with? We're going to substitute that little letter I with A cosine of C. In this equation, it's 2BI. See? This equation is 2BI. In this equation, it's 2BA cosine C. They're exactly the same, except that we exchange the I for A cosine of C because of what we did up here. And that's how we got it. Hopefully you didn't get lost on that one. If you will study Euclid Book 2, propositions 12 and 13, you will see an identical marking on their proofs as you just saw here. Except now, instead of calling the length of DC I, we're now calling it A times the cosine of C. Same length. It's sort of like when you have those variables and say you have 2 squared, but then you decide to disguise the number 2 with an x. Well, the value hasn't changed. It's just instead of a 2, you have an x. Same system. Alright, so hopefully that helped you out. I will tell you more in a future video. Stay tuned.